You've seen a rainbow 1,000 times. You've never actually seen what light is doing. Most of us think a prism just makes rainbows. Pretty light show, nice for a physics class demo, but that's backwards. A prism doesn't create color, it reveals what was always there. White light isn't pure, it's a crowd. Here's the real question. Why does bending light make colors separate? And once you know that, you'll see prisms everywhere in places you'd never think to look. Light travels in waves. Different colors are just different wavelengths. Red waves are long and lazy. Violet waves are tight and rapid. All mixed together in sunlight, they move at the same speed. Then they hit glass, and here's where it gets strange. Glass slows light down. But in this matters, it doesn't slow all colors equally. Violet light slows more than red light. That tiny difference in slowdown creates a tiny difference in direction. Red bends less. Violet bends more. Over the length of a prism, that small difference becomes dramatic. The beam splits. Colors peel apart like layers. This phenomenon, the bending of different wavelengths at different angles, is called dispersion. It's not magic, it's physics. But it's also the reason your world contains hidden color. Now here's what most people miss. You don't need a science prism to see this. You already own prisms. Your smartphone screen has one. Your watch crystal does too. Even a wine glass if the light hits it right. Water droplets are prisms. Ice crystals are prisms. That's why you see a rainbow after rain, millions of tiny water droplets, each one bending and splitting light. You're not seeing the rainbow. You're seeing the proof that light has secrets. But here's the strangest part. Different materials bend light by different amounts. A diamond bends light much more than glass. That's why a diamond sparkles. That's why it looks alive. A material's ability to bend light is measured by something called its refractive index. Glass is around 1.5. Diamond is around 2.4. The higher the number, the more the bend, the more the sparkle. This is why prisms matter beyond the classroom. Understanding how light bends explains why the sky is blue, why sunsets are red, why mirages exist in deserts. The atmosphere acts like a prism too. Air density changes with temperature and altitude. Light bends as it passes through different densities. That bending is what creates a mirage. Your brain sees light arriving from the ground and thinks it's reflection. It's not, it's refraction. Every time light enters a new material, from air to water, water to glass, glass to diamond, it bends. And that bending is never random. It follows exact mathematical rules. Newton figured this out centuries ago, but the wonder hasn't aged. There's one more layer. When light bends, sometimes it bends so much it bounces back instead of passing through. This is called total internal reflection. It's what makes fiber optic cables work. Light gets trapped inside, bouncing endlessly, carrying data across the world. Your internet connection travels through glass prisms. Your phone calls do too. Every color your screen displays comes from light bent and filtered through carefully designed prisms. Prisms aren't relics of old science. They're woven into modern life. So when you see a rainbow next time, pause. You're not just looking at beauty, you're watching light confess its nature. You're seeing the invisible made visible. You're watching a prism do what it does best, reveal what was always hiding. And now you know why. Light has secrets, prisms tell them, and once you start looking, they're everywhere. Subscribe so you don't miss the hidden physics hiding in plain sight.